Welcome back, everyone. For part 3, what we're going to do is set up the training for the model and also set up the evaluation. Let's get started. All right, here we are back at the notebook. Let's go ahead and start setting up our cell that it's going to conduct the training of the model. First thing that I want to do is I'm going to import time. That way I can set up a start time, which is going to be equal to time. And then at the end, what I'm going to do is once this is done training, I'll go ahead and calculate and print out the time that has elapsed. So at the very end of all this, I'm going to print out, using a little bit of formatting here, duration, and then we'll go ahead and print out, let's say, total time divided by 60, so we actually get it in a matter of minutes. So duration was this many minutes, and then here we'll just say total time is equal to start time, and then we're going to take our current time, we'll say time.time minus start time is our total time. Or really, it's the time difference. But either way, you get the idea. So we set up our starting timer, we'll do a bunch of training here, so this is where we'll do all the training and set that all up, and then at the very end, we'll calculate the total time that has passed and print out the duration. So this basically goes to the very bottom of the cell. So now let's set up our training. We'll go ahead and run this for 10 epochs, and you can choose less or more, it's kind of up to you, but as we experimented with this data set, we found 10 epochs was pretty much more than enough amount of training, and in fact you should get really good results after even things like 4 or 5 epochs. This data set is really actually quite easy to train on. So we'll say train losses is equal to, and we'll set this up as an empty list so I can keep track of my loss during training. And then we're actually also going to pass in our test set, so we can evaluate the train and test loss as we train for more and more epochs. And then we'll also keep track of what we get correct. So we'll say train correct, and then test correct. Technically, you don't need to keep track of these in order to actually conduct the training. These are just going to be things that are nice for visualizations later on. So essentially, we'll just label these our trackers. They're technically optional, but it's going to be really nice to visualize these. Now it's time for the actual training. We'll say for I in range of epochs. And what we'll do here is we'll say train correct is currently 0, and then test correct is also going to start off at 0. And then we'll run the training batches. So we'll say for batch or B, and then we'll say X train, Y train, in enumerate, and here we're going to say train loader. So what I'm actually doing here, remember that the train loader returns back the image and its label. And with enumerate, I'm actually going to keep track of what batch number I'm on with B. So that's what this line of code's doing. And then we'll go ahead and kind of say B is equal to plus equal 1, because this technically starts off on 0, so it doesn't really make sense to have batch number 0. So we'll say B plus 1 in order to essentially start at 1. So we'll keep that. And then what we're going to do here is say that our Y prediction, this is where we're actually making the prediction of the model. We'll say model, pass in our X training data, those are the actual features. But remember, I need to flatten out the images. So we'll view this as 100 by -1. This is where we actually flatten out the data. So recall, on the very first pass, this should perform horribly, because we're just saying, hey, our model with random initializations of weights and biases, go ahead and try to predict, based off the X training, what that Y label should be. So here we have our Y prediction, and then we should compare it to Y train in order to evaluate our loss. So what's the loss here? Well, the loss is simply passing this in to criterion and comparing our Y prediction to the correct Y training value. All right, now we're going to do a little bit of calculation here. Again, technically optional, but it's going to be nice to see these statistics later on. We'll say our predicted, so what we want to do is tally the number of correct predictions, is equal to torch max Y prediction dot data 1 indexed at 1. Okay, so this is a bit of a complicated line of code, but the idea behind it is pretty simple. Recall that at the very last layer, we have those 10 neurons. And what those neurons are essentially going to put out is their probabilities per class. So maybe they think there's a 10% chance of belonging to class 0, 0% chance of belonging to class number 1, and so on. And then eventually, one of these is going to have some sort of max value. So like 80% chance of being the number 9, because the neurons, the way it's formatted, are essentially one-hot encodings. So what I want to do is grab that data, and then along the correct axes, go ahead and grab that max value. And then I'm going to index this in order to get off the actual predicted value here. And then what I can do is, this is essentially transforming these probabilities into something that looks like, oh, predicted the number 9, just a single digit 9. That way, what I can then do is say batch correct is equal to, and what I'll do here is say predicted where you're equal to ytrain, and then take the sum of this. Essentially, how many matches do we actually have where my predicted value is equal to my ytraining value? And then sum that up, and that will give me how many I got correct off of that batch. And since I'm keeping track of this, we'll say correctly predicted during training is plus equal to batch correct. Now, if you have difficulty understanding what these terms actually look like, what I would highly suggest doing is running this for just like one epoch and then printing these out. So you can always, if you're ever confused at what these actually are, you can always just say, oh, you know what? Print out ypred so I can see it one time, or print out ypred data, etc. So if you're having any trouble understanding what these terms actually are, just go ahead and print them out, and you'll be able to see then visually what it is they actually are. Okay, so once we do that, we want to update our parameters. This is the same as we've always done. We go ahead and calculate where our gradient is 0, and then we're going to perform back propagation by saying loss.backward, and then optimizer step. Okay, so what I want to do is print out some results during the training. So we'll go ahead and say if our batch mod 200, so if the batch number is evenly divisible by 200, so it's equal to 0, we'll go ahead and print out the following. This is just reporting back some information that we can see during training. We'll say epoch, and this will be the epoch we're on, which is I, and then we'll say batch, and this will be the batch we're on, which is B. And then what I'm going to do is just, let's go ahead and print out the loss. And the loss is going to be loss.item. And then finally we'll print out the accuracy. And this is just going to be equal to, and here we're actually going to calculate accuracy separately, just so we save ourselves a little bit of space. Accuracy, that's going to be equal to the number of training correct item times 100 divided by, and then since we're on batch, we'll say 100 times B. Essentially just performing the calculation for accuracy. And then we'll input that here. In fact, let's just say ACC to save ourselves a little bit of space. So that's why we were kind of calculating all these things. So at the end, we could actually calculate the accuracy for this particular batch at this particular epoch. So think of these as number of correct per batch instead of doing number of correct per epoch. So this will be nice because it'll print out the reports as we go along. So we'll see multiple reports per epoch since we're feeding multiple batches per epoch. Next, what I want to do is update the training loss and accuracy for each epoch. So what I need to do is outside of this if statement and lined up with this for loop. So I'm going to zoom out just one more so we can see this. Right now, I'm lining up this statement with the for B right here. So check that out. What I'm going to do is say train underscore losses, and I'm going to append that loss. And I'll do the same for train underscore correct, and I'm going to append that number of training correct points. Okay, So that takes care of the training portion. What I want to do is I actually want to then run my test data during the training. So this will allow me to understand how my test validation is going down, and eventually after a certain number of epochs, I should see less return on the test data results versus the training results. So we previously discussed that in the theory portion of the lecture on overfitting. So we're going to try to create that plot here. In order to do that, we're going to say with torch and pay really close attention to the indentation here. It's really easy to make a typo given how much code we're writing right now. But I want to say with torch no grad, that way I do not update the weights and biases with the test data. I'll say for b comma, and then exact as before, except this time it's with the test data. We'll say x test, y test, and then we'll say in enumerate, and then we'll call test loader. And then off of this, we'll say y val. We'll go ahead and apply the model to that data. We'll say, given that x test data, and remember we need to view it. This time we're going to view it as 500, comma -1, because if we take a look at the original test loader we defined all the way back up in this notebook, recall that our batch size for test loader was 500 images, not 100. So we'll flatten it out to 500 by -1 because of that. And then what we'll do here, so that's flattening out that test. We'll say predicted is equal to torch, just as before max, except this time it's on y-val data along the one dimension, and then we'll index off of that to get the actual predicted value. And then we need to compare our test correct. So plus equals, and then we'll say, where does our predicted match up to y test? And go ahead and take the sum of that. Because recall, this sort of equals equals comparison returns either a true or false, which essentially is a 0 or 1. So we're summing this up, where is this true? How many actual matches do we have? Which is the same as saying how many correct matches do we have. And then once that's done, outside of this with statement, we'll update the test loss and accuracy for the entire epoch. We'll say loss is equal to criterion, where we have y-val, y-test. We'll say test losses dot append loss, and then test correct dot append tst underscore correct. Okay, so let's go ahead and do a quick review while we run this and make sure everything's running right. All right, so while this is training, I'm reporting back the loss and accuracy for some of these batches. So on batch number 200 of epoch 0, batch number 400 of epoch 0, etc. We want to see how the accuracy is improving, not just per epoch, but we can see as we feed in more batches, the accuracy is getting a little better. You'll notice that you should be getting pretty darn high accuracy, and it's not uncommon to reach 99% or above accuracy. But let's do a quick review of what we're doing here. We're starting off by keeping track of when we actually start the training. Then we're training for 10 epochs, and then we have these trackers here. These trackers are technically not necessary to actually conduct the training of the network, but it's nice because it allows us to print out some statistics, and later on we'll actually be able to plot some of these as well. Then for that many number of epochs, we go ahead and keep track of how many we're getting correct, not just in our training set, but also our test set. From our training loader, we're getting batches in. So this B, due to the enumerate, is keeping track of what batch number we're on. Xtrain, those are the actual images themselves. Ytrain, that's the label. We run a prediction based off that image after we flatten it out. And then we compare that Y prediction to the correct label on the training data. That's our loss. And then we perform some calculations here to actually grab the predicted value, see how many predicted values we matched up on Ytrain. We get the sum of that, essentially treating trues as 1. So we get how many do you actually get correct on that batch. And since we want to keep track of how many we got correct on the actual epoch, we'll say training correct. Then we run back propagation and print out a little report for that batch for us. And we append our training loss as well as how many we got correct during that training. Then we'll do the same for the test set, except we're not updating the weights and biases. That way we're not influenced by the actual test set. So we just run these for the test set, essentially the exact same process, and then we keep track of those metrics as well. And then finally at the end of this, we'll go ahead and print out the total time. So I just finished training on those 10 epochs. It took me a little more than a minute, so like 1.87 minutes. I have a really fast computer with really good CPU though, so don't be surprised if it takes you somewhere between 5 and 10 minutes to run this. At the end of this, you should probably be getting at least 98% or 97% accuracy. You can see here I'm reaching 99.2, so don't be surprised if you perform really well in this data set. This is actually a very simple data set. Coming up in the next video, we'll continue right where we left off here, and we'll plot the loss and accuracy comparisons, evaluate the test data, display a confusion matrix, and then also examine the numbers we missed on. I'll see you right where we left off in the very next video.